first bioacoustic regular pulsation. What does that mean? It means that if you are in your garden or in the forest or in any place in the world and that you hear some animal sounds, you're going to perceive that they are synchronized. They have common rhythms and they follow a same regular pulsation, which is like a musical tempo. How is it possible? Let's see with some musical programs. Now we're going to the Amazonian forest and we're going to hear some recordings made by the Brazilian ornithologist Marina Anciões that I thank. Here we're going to hear the first recording. We already see that we may identify some images corresponding easily to the sounds, like this one. We're going to hear the second recording. Okay, so this one we may identify too. So we're going already to measure the first one. We go to the first recording, hear it again, here. This is the right one. So we're going to cut at the beginning of the sound and at the end of the sound. Now I'm going to select, copy. I'm going to the marker and paste. Here we have a first one. We're going to see a second one we saw here. This is it. We're going to cut. Here. To select, to copy, we go to the marker and paste. And what do we already see is that these durations of the sounds are very similar. Here, here, and here. Now we're going further, and I've already done it for lots of sounds coming from the same species at different hours of the day and different birds too. So for you to be sure, I let you hear the whole recordings. What a beautiful chorus! So now that we are sure that it is the same bird, we're going to analyze the image to see if we see some relations of durations. Yes, we do. Here, the first sound coming to the second one is more or less exactly at the same place, has the same duration. And the third one also is more or less at the same place. So we already can confirm that this bird, whatever is the hour of the day he is singing, should follow a same pulsation. Now we're going to hear a second bird, which is the second one we have identified. So now we're going to hear the whole so that you may be sure it's the same sound. Okay, it is. And we're going to see if you already see that all the segments of these sounds are more or less equals. They have more or less same durations. Even if they have sometimes 11 or sometimes 12 sounds, they are following a pulsation. Now we are going to hear our famous friend, the rooster. We're going to see if we have another sound. Yes, we do. And we are very lucky that my neighbor has two different roosters with two different sounds, so that we may compare. So here are three sounds coming from the first rooster, and the blue ones are coming from the second rooster. And we're going to hear the chorus so that we be sure that it's only rooster sounds. Yes, it is. And now we're going to see if we see some mathematical relations. Yes, we do. The first sound of the first rooster is really the same duration as the first sound of the second rooster. And what do we see with the third sound? We see that the third sound of the first rooster is beginning earlier than the third sound of the second rooster. So, does that mean that they don't follow a same pulsation? We're going to study and see if they have a same pulsation or not. We're going to compare four sounds coming from four different birds. First, we're going to hear the first rooster. Yes. We're going to hear the second rooster. The first bird. And the second bird. Okay, so that we are sure. So, do we see some mathematical relations linking these sounds? Yes, we say that we already see that the total duration of the sounds of the rooster 1 and of the bird 1 are equal. You're going to tell me, I cut it here. Why did I cut it here? First, because my ear tells me that tia tia is not like tia tia or like tia tia. So because of my ear, but also because the ultimate sound is the most difficult to measure, but the distance, time distance between the first sound until the second sound and the second sound until the third one, we already saw before that they are constant, so that the ultimate sound is not that important now. So we're going to see other mathematical visible relations between these sounds. Here, the first sound of the first rooster and the first sound of the rooster 2 are equal, corresponding to the 2/3 of the bird 1 and the peak of intensity of the second sound of the bird 2. Here, we see that the beginning of the third sound of the rooster 1 is corresponding to the peak of intensity of the third sound of the bird 1 and the end of the sound of the fourth sound of the bird 2. Later, we're going to see some other relations that I let you see by your eyes. Here, this one, and this one. So the end of the fifth sound of the bird 2 and the beginning of the third sound of the rooster 2. In this one, we see all the segments of the bird 2. We see that they are more or less equal. But the first one is longer than the second one, and there is a little acceleration so that they're not perfectly equal, but maybe the average of it should be in the pulsation. Is it the case? Well, we're going to see, and for that we're going to measure. So here, on the position 27, I see here the exact time position of it, which is 43.036. To know here, I see the exact time position of this one. I made the operation so that I know the exact duration of the segment for the ultimate sound. Now, we're going to see the result. What do we have here? We have rooster 1 and rooster 2. Here, the total duration of the sounds of the rooster 1. Here, the duration of the first segment, which is the first sound, the duration of the second segment, the third one, and here, the duration of the second segment and third one of the rooster 2, because the first segment was the same duration. And we have the same thing for the bird 1 and for the bird 2. Here we see rhythms divisions. What does that mean? By 2, by 3, by 4, by 5, by 6, and so on. For example, on the pulsation 72. What is pulsation 72? This is it. It means that you have 72 beats in 1 minute. And divided by 2, you're going to have 1, 2, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and so on. So that we see that really rhythms, musical rhythms, are mathematics. Now, why did I choose pulsation 72? It's because when I was hearing the sounds in my garden in Amazonia, and when I perceived that all the sounds were following a same pulsation, I heard lots of recordings of lots of very different animals, like frogs, like insects, like crocodiles, like hyenas, like dogs, like whales. And the biggest surprise to me was that I found the same pulsation. And this pulsation was 72. So that's why I choose this one, because of my ear. Now we're going to compare the durations of the segments. And here we have some intense colors. The intense colors means that we have an exact coincidence of number, of duration, between the pulsation 72 and the segment. For example, here, the segment 1 of the rooster 1. On the 8th division, it has the duration 0.046, which is exactly 0.046, the division by 18 of the pulsation 72. So that we have a correspondence, exact correspondence between this segment and the pulsation 72. So what do we see? We see that we have a lots of very exact coincidence, especially for the bird 2, because the average of the 11 sounds of the bird 2 is perfectly coincidental with the pulsation 72. This one is corresponding to a division by 6. Why is it blue? It's because 6 is a multiple by 2 and 3. 2 times 3 makes 6. And here 12. 2 times 2 times 3 makes 12. And 2 times 3 times 3 makes 18. So the blue ones are multiples by 2 and 3. Here we have the green ones, which are multiples by 2. 2 by 2 is 4, 2 by 2 by 2 is 8, and 2 by 2 by 2 by 2 is 16. And the yellow ones are the divisions by 5, and we are going to compare the positions. But you're going to tell me, Isabelle, if you're going to divide a sound by any divisor, you're going to find some divisions, and you may find any pulsation. So, of course, it is true, and I made the same thing with the pulsation 73, so that we may compare and see why we're going to choose 72. So here, same thing, and the bright colors, the clearest ones, are when there are hundreds of seconds of difference with the segment of the pulsation 73. So here, for example, we have the division by 7 of the segment 1 of the rooster 1, which is 0.053, which is almost exactly the same as the division by 15 of the pulsation 73, which is 0.054 seconds. Of course, a difference of hundreds of seconds is a very little difference that our human ear really almost does not perceive. So, what do we see is that, for example, for the bird 2, the exact coincidences are really less important. And I made a comparison between these two pulsations. So, here we have rhythm divisions, and 4, 8, and 16 are considered multiples of 2. 6, 12, and 18 multiples of 2 and 3, and 10, 15, and 20 multiples of 5, and so on. We see significative birds segments with pulsation 72. We see 7. Why? It's because in the first one, we see that on position division by 2, we have 2 plus 3, 4 plus 5, 6 plus 7. So that's why we have here written 7. Here we see 2. What does that mean? It means that the green ones, which are multiples of 2, we see 2 coincidence, exact coincidence with the segments of the birds we analyzed. What do we observe now? The number of significative segments with the pulsation 72 is 26 to only 15 for the pulsation 73. And for the less exact coincidence, we have 16 to 16. So that we may already say that the pulsation 72 is much more precise than the pulsation 73. We're going to observe the number of correspondences by simple multiples, because it's going to help us to choose between the pulsations. And what do we see? With 72, we have 8 exact coincidences with multiple 2 and 3 to only 5 with the pulsation 73, and 7 and 9 to the less exact coincidences, which is not surprising because 73 is very near 72, so that we have a lot of coincidences less exact with this pulsation too. And by multiple of 5, we have 12 to 9, so that the pulsation 72 should be the right one, and my musical ear was correct. Now that we have done this very interesting thing, I have to say that here in the Wales, there was a scientist. I was hearing him, and suddenly I perceived that he was following the pulsation too. He hesitated and followed the next pulsation. I shouted, the human maybe should follow this same pulsation too. So I began to hear lots of recordings coming from all over the planet to see if we were following a pulsation, because we all know that there are rhythms in languages. And of course, the presence of rhythms is presupposing that there is a pulsation. So now we're going to hear some Portuguese. This is a radio recording, and we're going to see the image so that we see if we may recognize some forms and try to isolate them so that we may see if there are mathematical relations between them.
15 de setembro de 2010. Confronto entre policiais e traficantes de drogas na favela da Mangueirinha, em Duque de Caxias, Baixada Fluminense, deixou 6 mortos, entre eles cabo da PM.
So now we see that there are very interesting forms that we may recognize and isolate. For example, this one, the green one, it is very clear. This one, the yellow one, also is very clear. I cut it, and okay, I choose this one, which has a different duration, and this blue one too, and one more here, a brown one, so that we may see if it is combining. Here, this segment is coming from the Chinese, because later I studied Chinese and saw that it was a duration which was missing to help to see the mathematical relations. So we have the segment 1, we have the 2, the green one, we have the 3, the 4th, the 5th, and the 6th. Now, what do we see? For example, how did I do it? I saw this yellow one, and I saw that this one should be very comparable. So I tried. I copy, I went there with the cursor, and paste. Wow, isn't that wonderful? And then I did it for lots of durations. So you see that this one is very comparable to this one to this one. The 2 of this one are making this exact duration, and we're going further, and you're going to see that it is really combining. This comes from the Chinese, but the 3 of these ones are making this one. Here 2 makes 1, here, it is almost really perfect. This one is exactly the same. So the segments of the human Portuguese speech well, are really corresponding with mathematical relations so that we may identify a pulsation for the Portuguese. Now we're going to hear some other different languages. We're going to hear some Chinese here on the top. Well, I'm very sorry that I don't understand Chinese, and lots of the languages I recorded here, but I'm really sorry if there is anything shocking in it. But the subject was to analyze it to see if we are following a same pulsation, and I think we're going to make this analyze. So here some Chinese.
和村庄的一些人有关系。大概就在我10几岁的时候，我的邻居有一个大学毕业生，当然就是大家也都如果对大陆比较了解，或者说从大陆来的这种人都会知道。
Okay, so what do we see? With our segments, we see that this is perfectly corresponding to this one, this two with this one, this is perfect too, this one to this one, the middle of it, this two with this one, and we see that it's very easy to compare and that the Chinese speech should follow the same pulsation as the Portuguese. I let you see until the end of my work. Isn't that amazing? Here, 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 until the second 12. I didn't go further because my ear says that it's exactly the same. You may hear live or in recordings, it's not a machine problem. You hear this pulsation. So here we're going to hear some Hindi to know if this language, which is very different of Chinese, for example, should follow also the same pulsation. Let's hear some Hindi.
अरे भैया, पंडित जी ने पोथी बंद कर दी है। पंडित जी ने चश्मा उतार दिया है। पंडित जी ने आंखें मूंद ली हैं। पंडित जी चुप से हो गए हैं। भैया.
Okay, so what do we see? Yes, it is combining. The correspondences are perfect. This one with this one. I didn't analyze the silences, but it should be analyzing, and it's participating of this pulsation. Here, this one is perfect with this one. I let you see by yourself now that we know the principle of this demonstration. Here, the Hindi really follows the same pulsation. Now we're going to hear some Magyar, because the Magyar is a very different language coming from other linguistic source.
1937 őszén kaptam egy telefonhívást a Metro Goldwyn Mayer budapesti képviselőjétől, és azt mondta, hogy Mr. Mayer, a Metro Gold...
Okay, so what do we see with the Magyar? Here, this one to this one. Here, it's perfect. Here, this one, and here until the middle of this one. If I'm going to cut, we'll see it very clearly. Here, this one plus this one makes this one. This one is just perfect. And we see that the Magyar, if we may see better like this, is also following the same pulsation. Isn't that amazing? Until the end of my work, for you to see what is happening. So, we need to hear some Turkish, which is also a very different language. Let's hear some Turkish.
बैनर हम लेके गए थे कि हम पाकिस्तान के स्टूडेंट्स तरक्की के लिए स्टूडेंट्स के लिए प्यार मोहब्बत का पैगाम है, वो हमारे पीछे लगा दिया, खिड़की खुद जमीन पर बैठ के चादर बिछा के। थोड़ी देर में एक स्टूडेंट उनका
Okay, so what do we see with the Turkish? Yes, it is combining. Here these two are perfect. This one is perfect, this one too. So we see we're going to until the end of my work. We see that the Turkish is perfectly combining with the pulsation. Nature is really perfect. Well, nature, we may say nature has variation. Of course, in a human face, for example, we may say the two eyes have the same size. But we all know that the two eyes don't really have the same size. It's not perfect. But there is a law. We should accept that there is a law which says, well, in the human face, the eyes are the same size and the nose is in the middle of the face. Sometimes the nature makes some very little difference between two sounds or a sound with a segment. But we should say, as we say for the eyes, that we should accept that this segment is a part of the language pulsation. We're going to hear some Arabic, which is a Semitic language.
لا ذكر ولا أنثى رمادي ولو أشعلت فيه النار يتبعني ويكبر ثم يصبر كنت أمشي كان يمشي كنت أجلس كان يجلس.
So what do we see with Arabic? This one plus this one makes this one. This one is just perfect. And we're going further. I'll let you see. Of course, the Arabic is following this pulsation too. So what are we going to do now? We're going to measure the segments and to see if it is combining with the pulsation 72. And I made a map, human languages pulsation. So we have these segment durations, and what do we see with the pulsation 72 is that we have some coincidences on, for example, this very strategic place, because it's a multiple of 2, of 0.052 seconds, which is perfect. And here we have almost perfect, this one, division by 11, which is not that relevant, and near this division by 9, and also this one, which is not perfect. So what does that mean? The pulsation 96. It's because hearing so much human languages, I perceived that the pulsation 96 was better than the pulsation 72. So, is it because it's a different pulsation which has nothing to see with the other one? Well, I found the answer. No, it has a relation. 24 times 3 makes 72, and 24 times 4 makes 96. So that the pulsation 96 is relative to the pulsation 72. And what do we see with the pulsation 96? It's that the coincidence, the perfect coincidences with my segments, coming from the Portuguese, are on the position, strategic position 16, 12, which is multiple by 2 and 3, and 8, which is a multiple by 2. We really have some beginning of proof that the human languages are following the pulsation 96, which is a relative of the pulsation 72. Isn't that amazing? So now that I found this, I made some almost perfect segments with the right durations of the pulsation, and we're going to hear some more languages to see if it's combining. The Japanese, because Japanese have a special accentuation which is called mora. Let's hear some Japanese.
こんにちは。
私はあなたにいろいろな日本の詩を読むことを教える。私は俳句をちょくちょく書きますから、私のトピックを。
Okay, so what do we see? We see that the Japanese is perfectly combining with our segments. Yes, here, here, and we go further so that you may see that the Japanese is at the same pulsation. Okay, and to end this little demonstration, we're going to hear some Swahili, an African language, and verify that the Swahili is also on the same pulsation. Let's hear some Swahili.
Hizi tungo zina daraja, manake si mtu yoyote yaniuka akatunga mpaka ende kusomea au kusomeshwa mpaka aje awe yeye ni mshairi apate cheo awe.
Okay, sorry to cut. Here, what do we see? Of course, the Swahili is on the pulsation. Isn't that wonderful? I let you see until the end of my work.